Now we consider the following function: f of x given by x plus x squared plus e to the power x. Okay, we want to find the derivative of the inverse function at 1. Okay, so if we try to find the inverse function, it's going to be a bit difficult, because if you let f of x equals y and you want to solve for y, it's going to be difficult. Okay, but also we want to see where this function is increasing. Okay, so we note that if x is less than 0, e to the x behaves like 0. Okay, remember, when the exponential is, when we are close, when x is negative, e to x is like 0. So that means the x plus x squared dominate, and this is like parabola. Okay, so there is some suspicion that there might be a point where the function is increasing on some points and decreasing on the other. Okay, so but for us to find the one, we want to assume that x is bigger than 0. So when we do assume that x is bigger than 0, we are in this interval, and on this interval f is increasing. Okay, that means f has an inverse function. Okay, so that's one of the keys, because so f is not bijective. That's the problem with this function. But if we want to find the derivative of the inverse function at 1, so we can assume that f is defined only on this interval, so x positive. Okay, so for x positive. Another thing is that we know that f inverse, the derivative of f inverse at any point x, is given by 1 over f prime of f inverse x. Okay, so the problem is we know f, so we can compute f prime. In fact, f prime of x is given by 1 plus 2x plus e to x. So this is f prime. The issue is that, what about this one? How can we get this one? Because we want to find the origin, the inverse function, and find the image by 1. But note that f of 0 is 0 plus 0 squared plus e to 0, it's 1. Okay, and assuming that 0 is in this interval here, okay, we assume that we are here, so we assume that we are in 0. Let's make 0 here in this interval. Let's assume that working on this point, not 0. Let's assume that working from this point on. Okay, so from this point where we have the graph, let's say minus 0.5 up to infinity. Okay, so 0 in this interval, and f is increasing. Okay, but here we can say that we have an inverse function, and in this case we see that f inverse of 1 is 0. This would help us here, because here we want to compute f inverse of 1, which is going to give us f 1 over f prime, f inverse of 1 from here. Okay, if we let's plug it first. It's going to be 1 over f prime, f inverse of 1 is 0. And the derivative is known here. So f prime of 0 is 1 plus e to 0, which is 2. Okay, so that means the derivative is 1 over 2. This proves that f inverse differentiated at 1 is 1/2. Okay, we can also, to see this result, we can use some computer algebra system like TI 89 or maybe some, or GeoGebra. GeoGebra is great, or MATLAB if you know, or maybe Python. Why not? Maybe Python to solve this problem. Okay. Anyways, the derivative at 1 of this inverse function is 1/2. That's the result. And make sure that to see that this function is not bijective unless you put x in some values like between minus 0.5 and plus infinity. Thank you.